Hello, my young physicists. Let me start with a question. Have you ever noticed that when you stand in front of a mirror, your reflection seems to be staring back at you from behind the glass? Almost spooky, right? But here's the twist. Physics tells us the mirror isn't hiding a twin world behind it. In fact, the rule is simple. The image is just as far behind the mirror as the object is in front. Or in formula style, di equals do, where di is the distance of the image from the mirror and do is the distance of the object from the mirror. A mirror is like the fairest judge in the world. It always gives equal spacing, no cheating allowed. Now, how do we actually prove this? Let's play with some light rays. Imagine a mirror labeled mm1. Place a point object O in front of it. One ray goes straight to the mirror at point F, bam. It comes right back along the same line. Another ray goes to point A and then bounces off as ray AC. If we extend those reflected rays backward, guess what? They meet at point I, forming the image. It's like tracing gossip back to the original source. You'll always find the image at equal distance behind the mirror. Time to bring in the big guns, the law of reflection. Take ray OA hitting the mirror at point A. By the law, angle of incidence equals angle of reflection. That means angle OAN equals angle NAC. But wait, alternate angles come into play too. Angle OAN equals angle AOF. And corresponding angles tell us angle CAN equals angle AIF. So, triangles AOF and AIF are congruent. Fancy geometry just said, yup, the mirror keeps things perfectly balanced. As Thanos would say, perfectly balanced, as all things should be, except here no universe is destroyed. So what does this triangle congruence give us? Simple, side IF equals side OF, which means the distance of the image behind the mirror equals the distance of the object in front. And here's the best part, it doesn't matter which race you pick. The result always holds. The mirror is like a very disciplined student, never bends the rule, always keeps object and image at equal spacing. Let's test this with some numbers. Say you stand 10 centimeters in front of a plane mirror. Where will your image be? Well, the model says di equals do. So plug in do equals 10 centimeters. That makes di also equal to 10 centimeters. So you're basically saying hello to yourself, standing 10 centimeters behind the glass, except of course, you can't shake hands with that reflection. If you try, you'll just smudge the mirror. Been there, done that. Alright, let's wrap this up neatly. Plane mirrors always place the image as far behind as the object is in front. This comes from the law of reflection and congruent triangles. The image is virtual, erect, same size, and laterally inverted. In other words, the mirror gives us a faithful copy, but one that's reversed like a selfie camera. That's why you can check your hairstyle, or why drivers use rear-view mirrors to see cars trailing them. So next time you wave at yourself in the mirror, just remember, you're not seeing a magical clone. You're simply seeing light obeying the strict rules of geometry and reflection. I hope you enjoyed this journey. See you in the next session, where physics gets even more fascinating.